All right, here we are, lesson 2. We're going to be talking about measurements and calculations today, kiddos. Measurements and calculations. It's going to be dope. You're going to love it. So check it out. 1.2, measurements and calculations. What are we measuring? Let me tell you. Here's what we're going to be measuring in this class. And you probably have some experience with one of these. Distance. We use the metric system, all right? We're going to be like the rest of the world here. And in this class, it's usually meters or centimeters, sometimes even a kilometer, who knows? All right, 100 centimeters is 1 meter. 1,000 meters is 1 kilometer, okay? That's that. Time, all right? Sometimes we use seconds, minutes, hours. I label the units, you know what I mean. But 1 hour is 60 minutes. 1 minute is 60 seconds. You don't know that. It'll be a long class, low key. Mass. The unit of measurement is grams, but grams is pretty small. All right, like a nickel weighs 5 grams. It's a good way to tear your scale. And there's also kilograms. That's 1,000 grams. That's going to be more common. Force. All right, so if I'm pushing on something, we measure that in newtons or pulling as well. Okay. Joules. That's a unit of energy. Okay. And there's 1,000 joules in a kilojoule, because sometimes we use kilojoules because a joule isn't very much. Okay, so cool. So the first thing is we're going to talk about distance. Now, here's the deal. Kids get this wrong all the time, and it is crazy, but we're going to do it. When we are using a ruler, like pretend that I have 2 rulers here, ruler A and ruler B. When we are using a ruler, okay, you always have to estimate 1 digit. So let's look at this paper clip. If I look at A, okay, I know that this paper clip is between 2 and 3 centimeters long. But I don't just say 2 and I don't just say 3, I have to estimate a digit. So if I was using ruler A, I would say that this paper clip is about 2.3 centimeters long, okay? I'm estimating this digit, the 0.3. So I include 2 digits. Now, if I was using ruler B, okay, so if this first one, I only use 2 digits, one that is known, because I know it's more than 2 and less than 3, and one that is estimated. Now, ruler B, all right, I'm going to see like this right here goes, oh, it's like right there. It's right between this little tick mark and this little tick mark right here. So I'm going to say it is 2.25. Okay, the 2.2 is known and this 5 is estimated. It's 3 digits. So this ruler right here is more precise than this one right here because it has more of these little marks on there. Okay, so if you are measuring distance, or if you're using anything where there's like tick marks, kind of like a graduated cylinder in chemistry, or a spring scale, something like that, you always estimate a digit. Cool, cool. Now, this one right here, time, okay? In this class, we are always going to do something digital. We're not using like a sand glass. I don't know if those things are called sand thing. The hourglass, there it is. All right, here's the deal. Look for the colon or the period, all right? This one right here, I'm saying is 1 minute, 2 seconds, and these right here is actually a decimal, okay? So if I were to write this out, I would actually write 62.64. That's how I would read that, okay? Make sure you look for the colon and the decimal, okay? So if you see this 420, all right, then this colon represents probably an hour, so 4 hours and 20 minutes, okay? If it's a decimal, then you know that comes right before it is a second, okay? Scales, all right? A gram is the unit of measurement, but a gram's like less than a penny, okay? So we're gonna be using kilograms for the most part. So 1,000 grams and 1 kilogram. A kilogram, there's about 2 kilograms in every pound, more or less, okay? This is how much something weighs, the mass of something. Technically, something weighs a little bit different than mass, but whatever. Forces, remember, that's whatever push or pull. There's 2 different ways. If you did this in class or you use this for near, this right here, you can push and pull on something and you can measure it and it will say like, hey, that's what the force was and it's in newtons, okay? Anytime you're reading anything digital, just write down all the digits that it gives you, okay? If you're doing something that's 0.34, write down 0.34. You don't round it if it's digital, okay? Now this one right here, this is a spring scale, okay? This spring scale, let's say you're pulling on it and it pulls it to right here, and see how this thing kind of has a curve? Well, this is the exact same way that you'd be reading a graduated cylinder in chemistry to get volume, okay? And you go with the bottom, okay? So if this right here is it, this is 30, this is 40, so that means this is 31, 32. It's right below 32. So I'm going to say, remember, I'm going to estimate a digit, 31.9. Oh man, 31.9. Who wrote that? I did. Talking to myself. All right. Energy. So energy is measured in joules. A joule is basically how much energy it takes to warm 1 gram of 1 degree Celsius. Actually, that is a calorie. That is incorrect. So that's like 4.184 of those. We are just going to say that a kilojoule is a unit of measurement. All right, there's 4 kilojoules in 1 calorie, more or less. But let's say you eat something, and that something has, let's say, a bag of chips, and that bag of chips has 150 calories. Well, that means it gave you about 600 kilojoules worth of energy. All right, so the energy that food gives you, it's a type of energy. There's other types of energies. We're going to be talking about potential energy and kinetic energy, but it has the same unit of measurement, which is kilojoules. Okay. The last one, we talked about this, which is force. In general, the Newton is the amount of force necessary to accelerate 1 kilogram. So force can be a pull. I should have had that earlier. So a lot of kids ask, like, how many digits do I write? So if you are measuring it, if it's a digital measurement like time or anything that uses like a digital reading, just write down all the measurement, all the numbers. Now, if it's something that you're manually doing, like a spring scale or a ruler, remember to estimate 1 digit. Did you calculate it? Now, sometimes you do some math and you do some calculations and you get a bunch of numbers, all right? If I say like this right here, do I write down, how many numbers do I write down? Well, that depends, okay? And that depends on how many digits were in the measurement to begin with. And we're going to talk about that in just a moment, okay? And we're going to round your answer to that number of digits. So I'm going to come back to that. So let's say I'm measuring how long it takes me to eat an entire pineapple. Well, this is 4.5 hours, 4.3 hours, 4.20 hours. I want to calculate the average. I add these up, divide by 3, and I get 4.33333333. So your question is, how many digits do I write? Well, I look at these measurements, and I notice this one has 3 digits, this one has 2 digits, and this one has 3 digits. Okay, so what I'm going to do is I'm going to find the one that has the least amount of digits, and in that case, it's 4.3. And I'm going to round my answer to however many digits that has. That's called significant figures in the biz, all right? So my answer is, if this has 2 digits, then this right here is going to have 2 digits. So 4.3 is my answer. Okay, so here are the 2 types of calculations you need to know how to do this class. Averaging. You add them up and divide by the number of trials. Okay, so 2.45 plus 2.68 plus 2.98, add them together, then divided by 3. I want to show you something. This is super important. Watch this. 2.45 plus 2.68 plus 2.98 equals that number, and then divide by 3. And I get 2.70. Okay, now look at this. I look at this. Ooh, that is 3 digits, 3 digits, 3 digits. That means my answer needs to have 3 digits, 2.70. Remember how it was a bit extra on that equals thing? All right, check this out. I see kids do this all the time, and they get the wrong answer, and they get the wrong answer, and they get the wrong answer all the time because they don't do the equal sign. Check this out. You ready for this? It's crazy. 2.45 plus 2.68. Ooh. 68 plus 2.98. Now I'm not going to press the equal sign. I'm just going to go divided by 3 equals 6.12. Is that the right answer? No, it is not the right answer. What happens is, if you don't press the equal sign, it's like you don't have this parentheses, and this 2.98 is divided by 3, and then you're adding it to that. So make sure when you add these up, you press the equal sign, okay? Now this one right here, I have 4 trials. So I add this plus this plus this plus this, I divide it by 4. You do that, you get 8.555. But now let's look at these. I have 3 digits, 2 digits, 3 digits, 3 digits. So this one right here only has 2 digits. That means my answer can only have 2 digits. Bam, 8.555 rounds to 8.6. That is that. Margin of error, even easier. You take the biggest value in a set of data, you minus the smallest value, divided by 2. So I look at these, I look for the big one. Oh, 2.98. Minus the small one, 2.45. Again, press equal. I don't know what this is, but press equal. Then divide by 2. 9.6 minus 7.4, because this is the biggest and this is the smallest. Press equal, divide by 2. When you're writing the calculations, write plus or minus before them. Okay? Okay. That's all I got for today, homies. Check it out. You have a little discussion where you come up with your own experiment and identify your variables, and then you have to respond to someone else. Be like, dude, that's awesome. Have you ever thought about this? And then a little bit of them, that's what you're watching right now, is this presentation. And then there's an assignment, and then there's a quiz, and that's it for the day. I will talk to you later. You take it easy. Email me if you have any questions. Catch you on the flip side.